Sorry, there's more people coming. Just give me one sec. Yeah, I know. Okay, guys. Right. So I got stuck on question 11 yesterday. So I'm going on page 155. So I'm going to go back and do that one first. Okay. So it says show how the present value of an annuity involving depositing 3,000 per year. So there's 3,000 deposited per year at an account for 6 years. So 6 years. And it's 8% per annum is the interest rate, and it said calculate the present value. Okay, and really important, girls, they're paying at the start of the year, right? So basically, instead of paying 3,000 per year, if you were to just get a lump sum and put it in and say, well, this represents 3,000 a year, right? How much would you need right now, right? So for the first year, you definitely need 3,000 euros because you're paying at the start of the year. So you'd need the full 3,000 euros, right? For the second year, you wouldn't need the full 3,000 euros. You'd need the 3,000 euros without the interest, okay? Again, because it's, if it was, that's year two, but it's at the start of the year, so you've only got 1 year interest, okay? The next one, it's 3,000 divided by 1.08 to be squared, and then plus dot dot dot. The last one will be 3,000 divided by 1.08 to the power of 5, because it's 6 years. So this is year 1, 2, 3, 4, 5, 6. Okay, is that all right? Okay, so that's, you want SN. So you want to know how much that is worth right now. Okay, so SN is A times 1 minus R to the power of N all over 1 minus R. So that would be A is 3,000. 1 minus R is 1 all over 1.08 to the power of 6, because it's 6 years, all over 1 minus 1 all over 1.08. Okay, and into the calculator with that, and you get whatever you get. Okay, I did the future value next year or yesterday, but I'll do it again just for completeness. Okay, so for completeness, the future value is, right, actually I'm going to work out all that there, because it's just important that I talk about it. Okay, so I'm just going to work it out. So 3,000 open bracket 1 minus 1 over 1.08 to the power of 6. I don't know what I'm actually doing there. Hang on a sec. I'll just start again. 3,000 bracket 1 minus 1 over 1.08 power of 6 close bracket all over 1 minus 1 over 1.08 equals 14,978. Now the pin won't right. 14,978 euros and 13 cents. Okay, so instead of saying I'm going to put in 3,000 every year, right, I'm going to put in, if you just put 14,978 euros, you'll end up with the exact same amount. Future value is how much is it going to be worth. Okay, so basically you're going to put in 3,000 every year for 6 years. So how much is that going to be worth you? So that's 1.08, so you're going to get interest for the first year. Then you're going to put in 3,000 on the second year, so you'll get interest for the second year. Sorry, this is written backwards. Okay, so the first €3,000 you will get interest on it for 6 years. The second 3,000 you'll get interest on it for 5 years. The third 3,000, etc. The last 3,000 you'll only get interest on it for 1 year. Okay, so again that's a series. So it's A is equal to 3,000 times 1.08. 1 minus R in this case is 1.08. The power of n is 6 all over 1 minus R, which is 1.08. Okay, into the calculator with that. Okay, and that would be 3,000 multiplied by 1.08 multiplied by 1.08 to the power of 6 divided by minus 0.08 equals, oh, why did it do that? What did I do wrong now? Sorry, just give me a minute now. I typed it. Oh yeah, I see my mistake there. Right, okay, and I've got something crazy because I've typed in something wrong. 1.08, oh, I forgot the 1 minus. $23,768 and 41 cents, right? So if you were to invest the money, 3,000 per month, if you come back in 6 years time, that's how much you have, right? Okay, if you were to put this cash in right now and come back in 6 years time, that'd be how much you have, right? Okay, and that's what they ask you to do in part 3. Right, if the present value, so we said the present value is 14,978.13, right, is put in deposit on a single investment. Okay, so this is, we're just going to, final amount is equal to the principal times 1 plus I all to the power of t, just that formula. Okay, so final amount, if you were to invest 14,978 and 13 cents into that account at 8% per annum, so it's 1 plus 0.08 for 6 years, you will get 23,768.41. Okay, thanks. That's number 11 done. Okay, then on the next page, right, then I went into the amortization formula, which is it was probably like doing Japanese, but listen, I hope you were able to make head nor tail of it last night, right? And I gave you page 157, 1, 2 and 3. Does anyone need me to do number 1? Yeah?
Yes, please.
Okay. So, number 1, calculate the monthly repayments. So, monthly repayments, very important, monthly, right? Okay, so we want the monthly repayments for a mortgage of 200,000 paid over a 30-year period at an annual interest rate, so it's 6% per year. Okay, now we have a problem, okay, because we want the monthly repayments. Okay, so we're going to be using our amortization formula, which is P times I times 1 plus I to the power of t all over 1 plus I to the power of t minus 1. That's the formula we're going to be using in a minute. This will be the monthly repayment. Okay, but this has to be, because I want monthly repayment, I need the monthly interest rate and I need the time in months. So if you want the monthly repayment, everything has to be in months. Okay, I have a yearly interest rate, so I need to change that to a monthly interest rate. And I have a 30-year period, I need to change that to months. Okay, so what I'll do is I'll change the interest rate first. Okay, so if I were to get €100, after 1 year I would have €106. Okay, So the final value is equal to P times 1 plus I to the power of T. Okay, so I had 106 euros after 1 year. I put in 100 euros. I'm looking for the monthly interest rate, which is I, and the time now is in months to the power of 12, right? Then that's 1 plus I to the power of 12 equals 106 divided by 100. Get the 12th root of each side, and you'll end up with 1 plus I equals 106 divided by 100 equals, why didn't I just do, sorry, 12th root of 1.06 equals 1.0048, 1.004867551. Now the more decimal places, girls, you use, right, okay, you might be tempted to round that to, when you subtract the 1, you might be tempted to round it to 2 or 3 figures, but I would recommending type in as many figures as you can, because the more accurate, more figures you type in, the more accurate your answer is going to be. And sometimes they penalise if you're out by, you would be out by a couple of cents, if not more, if you dropped all the decimal points. So keep in as many as you can, okay, unless they tell you to round, obviously, right? But if they don't tell you to round, I'd keep them all in. Okay, so there's my monthly interest rate. Okay, then my 30-year period, girls, in months is 30 by 12 is 360 months. Is that okay? So then you're ready to fill in now. So your A is your monthly repayment is equal to the principal, which is 200,000. I is your monthly interest rate, 0.0486751 times 1 plus 0.00486 dot dot all to the power of 360 all over 1 plus 0.00486 all to the power of 360 minus 1 into the calculator for that, and round it up to 2 places decimals because it is money, right? Would it be okay if I didn't do that? Right? Is that okay? I'll take that, yeah. Right, that's number 1. Anyone need number 2 done? They're giving you the repayments per month. So again, you have to change the interest rate. It's 8% per year, and number 2, you have to change it into a monthly repayment rate, right? Okay, you have to change 20 years into 240 months, and you'll be working backwards. You'll have A, you'll be missing the P, and you'll have everything else there, right? Does anyone need me to do it? No. Right, number 3. Does anyone need me to do number 3? Oh, okay, great. Right, I have a big long example that I wanted to do that I meant to get to yesterday, but obviously I had a lot on yesterday. So example 2. So what I'm going to do is I'm going to leave you write it down first, and then we're going to do it. Okay, so Rena borrows 50,000 from a bank to fund new machines for her business. She agrees to repay the loan plus interest by a series of level annual repayments, starting 1 year later and continuing for 6 years. Interest rate is 7.5%. Right? Find the amount of the annual repayment. Construct a schedule. This is why I'm doing this example, because I want you to see this. Construct a schedule showing the interest and the principal, and at the end of the 4 years, Serena clears the loan. How much does she need to clear the loan? Right, we good? I take that as a yeah. Okay, right. So the first part, find the amount of the annual repayment. That's just the amortization formula. So A's and its annual repayment, and everything's in years, like the length is in years, the interest rate is in years. Interest rate, that should read 7.5% per annum. Okay, so principal is 50,000. The interest rate is 7.5%, so 0.075 times 1 plus 0.075 to the power of how many years did we say? Years for business, 6 years, right? Okay, and that's 1 plus 0.075 all to the power of 6 plus 1 into the calculator with that, and when you work that out, it'll be 10,652 euros and 24 cents. So that's her annual repayment. So every year she must pay them back this much. Okay, so that's the easy bit. That's the bit we were just on to, or we've just done. So this is the reason I'm doing this, because I want to show you what amortization actually means. Okay, so it says write out her schedule of payments, right? Okay, for the first for the loan. Okay, so what we have is year. We have the year, fixed payment, how much she paid them, right? How much of that was interest, right? And then how much was the principal and what was the balance on the loan. Okay, right? So so year 0, she obviously paid them nothing. There was no interest. Principal balance basically 50,000. She borrowed 50,000. Okay, then we've just figured out that her payment for the first year every year was 10,652.24. I'm going to write that down for every year, because 10,652.24, 10,652.24, 10,652.24. So 10,652.24 and 10,652.24. So that was her repayment every year, right? Okay, so of that, right? Okay, of that she pays the interest for the year plus a bit off the loan. Okay, so for here you need to work out the interest for the year. Okay, so the interest for the year. So the loan was 50,000, right? Okay, and it's 7.5, was it 7.5% interest it is. So let's get 7.5% of 50,000. Okay, so 50,000, I don't need to do this, 50,000 multiplied by 0.075 is 3,750. Right? So of her payment, she paid them 10,652.24, right? Of her payment, there was 3,750 was interest. So that means the balance, so 10,652, take away that. So that means she paid 6,902.24 off the principal, right? Okay, so she used to owe them 50,000, so she's paid them the interest for the year, and now she can knock this much off the loan. So you take that away from 50,000, so she only owes them 43,097 euros and 76. Okay, does everyone see where I came up with all those figures there? Our fixed repayment is part 1. Our interest is 7.5% of what she owes them. So you get 7.5% of 50 grand and you get that much. Okay, so her repayment consists of, she pays the interest for the year and whatever the extra bit is off the loan. So she paid them 3750 interest and she took 6,000, these two bits add up to her total repayment. So she took that off the loan, so she only owes them 43,097 euros and 76 cents. Year 2, right, okay, she again pays them her agreed repayment, right, the interest, right, the interest is now 7.5% of the balance. So you get 7.5% of 43,097 euros and 76 cents, right, okay, when you get 7.5% of that, it is 323233. So that's how much the interest for the year was that year. So let's see how much she's able to pay off the loan. So that was her repayment. So the repayment, take away the interest, is how much is coming off the loan. So when you subtract 10,652, take 3232, right, you get 7,419 and 91 cents. So that much is how much is coming off the loan. So she owed him 43,000 and whatever. Now she's going to pay them back 7,400, right? Okay, so her loan balance now is 35,677 euros and 84 cents. Okay, right, the next year, right, she pays them this much. The interest is 7.5% of the balance now, so you get 7.5% of that, which is 2,675 and 84 cents. That's how much interest she pays for the year. So how much comes off the loan? So you 10,652 take away 2,675, right, and that will leave me with 7,976.41. That's how much comes off the loan, right? So her loan is only 27,701 euros and 44 cents. Okay, the next year she pays them this much. Her interest is 7.5% of the balance, so you get 7.5% of that, which is 207,761. So what she paid, take away the interest, is what comes off the loan. So this year there's 8,574.64 coming off the loan. So 27,701 take away 8,574, right, leaves me with 19,126 euros and 80 cents. Okay, the next year she pays them this much. The interest is 7.5% of the balance. So the interest for this year is 1434.51. So this is how much she paid. This was the interest. So that means 9,217 euros and 73 cents came off the loan. So the loan, take away that, and she only owes them 9,909 euros and 6 cents. Okay, so the following year she pays them this, so you get 7.5% of that. 7.5% of that is 74318. So let's work out what comes off the loan. It's 10,652 take away 743 that, so that's 9909.06, and look, that's what she owes them, so that comes off the loan and she's done. Okay, so that's what amortization, girls, means. That's what I was trying to get at yesterday, that the repayments are your interest for the year plus a bit off the loan. Okay, so you pay the interest for the year. Amortization, that's what it means. You pay the interest for the year and you pay a bit off the loan, right? Is that okay? And part 3 of that question says, if she was to clear it off at the end of year 4, how much would she pay them? And she would pay them 19,126 euros and 80 cents. Okay, is that alright? Okay, so I'm going to see you in person on Monday. I'm so excited. I hope you're as excited to see me. I'd say you're not even there. But at least I know you're in front of me and bored out of your trees in front of me, as opposed to bored out of your trees on the computer. Right, okay, and I won't feel like I'm talking to myself. Okay, so what we're going to do is we're going to do the last few questions in section exercise 5.4. So page 157 to 158, 4 to 7 please for Monday. Okay, and that's this chapter finished. So on Monday I'll load up a few exam questions for you on financial maths, and we've a few proofs to do next week, and then the following week after that will be full on exam papers, but I'll be starting financial maths exam questions next week anyway. So after that then it'll be full on, so one more week of kind of bits that I just have to wrap up, and then exam papers after that. Okay, so there's your work for Monday, and you can head off when you've it down. Okay, and see you on Monday.
See you Monday.
Bye now.
See you Monday. Thank you.
Bye now.
Thank you.